and you know that we are recording. And let's start with, or let's continue where we were left yesterday. If you recall, we saw, or we have seen, how C actually allows us to create new data types, new types that we can use to represent things, right? So the specific method that we have seen is what we call structs or structures. And structures are actually a way of defining new data types based on existing data types. So a data type, if you recall, a type involves two things. A type is gonna be defined by two things. One is, the first thing is a set of values that we want to actually have represented in this type. For example, for integers, it's all the, let's say, integers, natural numbers in general, but these sets cannot be infinite in computer. We are supposed to be actually able to store them. So usually this set is finite set. Finite in that we have only a number of them. We have a countable number of them. We can count them. Like integers, for example, for a 4-byte integer, we know that there will be, let's say, on the order of a few hundred thousands or a few 10,000s. And if you have an 8-byte integer, it will be many more than that, but it's not going to be infinite. It will be a finite number. Okay, so a type will include a set of values, and then the second part is some sort of operations that are allowed on these values. Okay, allowed on the values. And we'll know, I mean, in the programming language that we are talking about, C programming language, there has to be a way of, let's say, storing these values, and then there has to be a way of, let's say, allowing us to write operations on this. All right. Now, we have seen the basic types like integers and floating point numbers, and then double float numbers, and then characters and so forth. So these are simple basic types that actually C allows us to actually, or C provides us with. C says, okay, these are available. All right. Let me see if I just remembered. Yes, I am recording it. Good. Now, and C said it will allow us to actually define our own types. So the type definition in that case will require at least the set of values, the finite set of values to be defined, right? And one possible way was, we have seen this enumerated types, right? And then another possibility was that actually if we have a set of values, set of integers, for example, or set of, let's say characters, or set of floating point numbers. In that case, we had these array types, right? Now, we have seen yesterday a new mechanism to do this one using structures. And structures are actually simply a way of combining different sets of values together. For example, if you recall, we have this complex number, the representation for a complex number, and we said a complex number is actually two numbers together. So two numbers, two floating point numbers. So one number here for the real part of that complex number, and then another number for the imaginary part. So if you can see that actually double number is a set, is a type, and this is a type, and the combined complex type is a combination of these two. What type of a combination is this? If you think of in terms of set operations, these are actually simply a cross product or a Cartesian product of these two things. So you have one set, a double set, double numbers, and then you have another set, which is a double number as well. And you take one double number from here, from this set, another double number from this same set perhaps, and you just combine them and actually get a combined number, two numbers. This is a new set. This set is comprised of, or is actually comprised using the two sets and Cartesian product of these two sets. And the way that we were actually doing this very simply, this mechanism was very simple. As you can see here, this is the mechanism to do this one. This says I have two double numbers. So I have two double numbers, meaning I have two sets, one double set and another double set, and I'm making a Cartesian product. And this is, let's say, getting one number from first set and another number from, let's say, second set. And then this is my now new number. This is a tuple in this case, and this is actually a new number. So if I added, for example, here one more thing, then what I would be doing is I'm taking the first set, a second set, and the third set. So this is also a tuple which have 3 elements entries in it, and this is also a Cartesian product of these three sets. So I can make it 5 sets, 10 sets, and so forth, as many as I want. All right. So, and we said we can treat these things, these types now as abstract data types, as abstract types, if we also define certain operations allowed on these types. So we said, okay, if I have for example, a conceptual complex number from math, I know that complex numbers are actually two real numbers, and they can be actually added together. They can be multiplied. They can be subtracted from each other, and they can be divided to each other, perhaps. And then we can get also the imaginary component of a number, a real component of a number, as well as the absolute value of that particular complex number. So these are the regular things that conceptually or semantically defined operations on these numbers, on these complex numbers. And we said, okay, we can define them. Once we define them, given the definition here and these functions, you can expose these operations to outside world, along with this part, how you actually represent your number, complex number. Then the outside world, now they can use these operations on these numbers without actually knowing the details of how those operations actually are implemented. So therefore, this term abstract data type, where abstract means I don't need to know about the details of the implementation, but I just know that if I have two complex numbers, I can add them, I can subtract them, I can multiply them, and I can actually divide them. Also, if you give a single complex number, I can take an absolute value of that complex number. Perhaps I would probably need something like setting a complex number and maybe printing a complex number so that I can actually see what my operations are doing. Then this will be a complete abstract data type where you can now expose only these functions, the definition of these functions, but you don't need to expose the implementation. And we have seen yesterday how to actually implement those definitions. One was, for example, reading it. So in this case, we are reading a complex number. So the complex number is going to be returned from here. So this is a a pointer argument. Therefore, the caller, for example, if I have a code segment where I actually defined a complex number, complex T as let's say my first number C1, and I say, okay, I use this scan complex function with an ampersand sign in front of this. This is ugly. Let me erase this one here and do this again. So I can read this one using complex or scan complex, of course, scan complex using ampersand C1. So this will actually, this scan complex function will fill in this C1 C1 variable. C1 variable is complex type, and complex type I know that has two numbers in it somehow, but I don't need to know the details of to be able to use this function. I don't need to know the details of this function. Of course, we are interested in the detail because we may need to implement this this part of the function. In this case, what we are doing is we are reading two parts of the thing. So the real part and then the imaginary part. And if you recall, if you send a structured variable, structured value, or structured, let's say, variable data as a pointer to a function, then you can access, in this case, the variable name is C, you can access the components of it using an arrow sign. And then the name of the component. In this case, we have real or imaginary. Real for REAL for real and imag for imaginary. All right. So here it is reading it, and then it is doing some fancy stuff afterwards. It says, okay, if I have read two numbers, the status is 2, meaning you actually gave me really two numbers, you meaning the user, then I will actually give a status 1, meaning I have read a complex number. If that is not the case, but you cannot read anymore from this thing, then this is apparently if it actually reached the end of file and there is nothing to be read from the file or from the, in this case, from the standard input, then I will set the status to 0, meaning I haven't been able to actually, I didn't read, or I couldn't read the two numbers that I require to define this particular complex number that the user is entering. Now here, we have to be a little bit careful. We have one slight thing here. You can see that I have this ampersand sign, which is necessary. Why is it necessary? Because I want to read something in the real part of the number. So in the structure, if you recall, there is a double real and double imaginary. And double real, I need to read it from the outside. So this is proper. This formatting is proper, but I need to send an address of that double number. I cannot send this guy because this will actually not fit the format. This is a pointer to a complex number. A pointer to a complex number, which is not going to work. Or this is already the pointer anyway, so this is going to pointer to a pointer. So this is wrong. So I cannot use just C because this is a pointer to a complex number. What do I need here? A pointer to a variable which is of type floating point number. It should be either a float or it should be a double, right? So therefore, I need to actually access the this part of the thing has to be a floating or double float or double typed variable. All right. Now you might ask, how do I know which one is which? So does this actually say that I am taking the address of C and then looking at the imaginary part of that, assuming that address of C is, let's say, complex T, a variable to complex T, and then I am getting the imaginary part of it? Or is it such that I am getting actually, so you can interpret this two ways, right? You can say this is perhaps this way, this imaginary, or it is this one. Okay, which one is correct? The first one or the second one? Someone answer me. So the question is, this guy can be interpreted either this way or I don't know, maybe interpreted this way. Which one is the correct one? The first one or the second one? Somebody. The first one. The first one says the answer. What he's saying is that this makes sense. First of all, why? Because I need to actually send an address of a variable or address such that it actually includes a space for, it is actually a space allocated for a floating point number, or float or a double. In this case, I think it is a double, all right, because of long f, right? So this one though says, I'm taking the address of C. What is C? C is already an address of type complex T. And now you are taking the address of that, which is an address of complex T, which is not defined actually in this case. It doesn't make any sense, right? And then you are assuming that that place has that address, that specific address has a double number in it, or a place allocated for a double number, which is not possible. We don't know what that address actually is saying. We have this thing, C is actually referring to here. This is my caller. If I have a caller C1, for example, C1 might be referring to here, right? So this is the imaginary part, and this is the real part and the imaginary part. So let's say if the real is first, it has to be the first one. It has to be let's do it this way. So the first part is the real part here. The second part, the imaginary part. Now, when I send it to this function, now I know that C is actually referring to here. C is in memory here. C is actually this guy. And there is an address here. And this address is supposed to be pointing at exactly here. All right. So now you are saying that if you do this one, you are saying that take the address of C, which is the address is here, right? Right. So C has an address. And then you are saying that now interpret this part as a structure which has real and imaginary part. There is no such thing here. This is not actually proper place or proper allocation. This is not allocated properly for interpreting it this way. So this should cause a problem, right? So semantically it's not right. So how do we know that C handles this one? C cannot actually say, okay, let me try this one. Does it make sense? If it doesn't make sense, then I do try the other one. That's not the case, of course. What C does is, C said, okay, I will look at actually who has the priority precedence to actually check for. And if you recall, we have this table, and we have been looking at this table for a while for knowing which operator has priority over the other operators, who comes first in actually execution. So this says here on the top of the chain, top of the thing, the ones that will be actually evaluated first will be the parentheses, either the regular parentheses or square brackets, or dots or periods. And these periods, if you recall now, we know that they are used to actually access the component of a structured variable, right? And then the same thing for at the same level, this arrow, as well as the postfix and prefix, postfix increment and decrement. These are actually the order. This is the order. So this will be the first. So if I have, let's say, and C, and let's say imaginary, then I know that in this thing, looking at this list here, I can easily see that in this list, you can see that, right? This part is going to be first because it comes in this order first. And ampersand is where? The ampersand is in the next part. So this one comes second. So this will be first in order, and this will be second in order. All right. So you need to know this, and it makes sense this way anyway. We would actually go for the parentheses or square brackets first, and the selection operator either for a structured variable or an address, a pointer to a structured variable. All right, and then postfix increment and decrement. Postfix, not prefix. Then the second part is actually prefix increment and decrement, unary plus and minus. These are unary. If you recall, unary is not a binary, which means, for example, +2 is a unary plus operator. And then this not equal, this bitwise, these are bitwise not operator and bitwise complement. And then a typecasting within the parentheses, and then the indirection or dereference operator, or the pointer indirection operator, and then the address operator, the ampersand, and then the size of function. This is kind of a function, and that comes in that order. And then goes the multiplication, division, and modulus operators, and so forth. Someone's microphone is on. Please mute your microphones. All right. So now we know that this will come first and the address is going to come second. All right. Let's look at another function of this. For example, printing a complex number. When I actually am printing a complex number, I don't need to send perhaps my, let's say, my address to the structured variable. I may send the variable copy of the variable itself, copy of the data. Of course, this is kind of expensive. This might be expensive. One alternative could have been here for doing something like this: print complex. If I want to avoid copying of the ingredients of C, content of C from the caller to callee here, I can actually do it this way: const, and I can say complex T and the address of a pointer to that one. Of course, if I do this one, my code is going to change. The dots are going to become arrows. Each of these dots are going to become arrow. Yeah, they will become arrows. So where do I have them? Just there. That's it. Those are the only two places I have the selection operator. This is the field selection operator or component selection operator for the complex type or the structured type that I actually implemented. So I hope you can understand or appreciate the difference between this guy and this one, right? This one is copying the content of the complex number from one memory place to another memory place to making a local copy. And then it will be actually doing the operations. This way, I am saying, okay, I will actually just send the address. I will keep the local copy, but this const in front of this declaration is going to guarantee me that this function here cannot do such a trick like C real equals something. So this will not be possible because of this const. Const says you can never ever change this complex, this number, this variable here, the content of this variable, whatever it is pointing to. This is a pointer. Whatever this pointer is pointing at, you cannot actually change that. This is const is actually allowing or preventing you from doing such a thing. All right. So another one, for example, adding two complex numbers and returning a complex number. Now you have the return is a complex number and addition is two complex numbers. Here again, I am passing a value. When I say I am passing a value for C1, I have two double numbers being sent to C1 and two double numbers for C2. So two double numbers for C1 and two double numbers for C2. And at the end of the function, I am returning and copying two double numbers for C return, C sum in this case. All right. So can I actually change and do this in a, let's say, in a different way? For example, let's actually do it this way. What I want to do is I want to change this function. I want to do another add function, but this add is going to be something like this. If I have add, let's say, C1 and C2, what I want to do is I want this to be doing this thing, C1 plus C2. Let's say that this is supposed to be the semantic of this code. So I want to write an add function operating on two complex numbers, and it will be adding the content of the first number with the second number, and it will be changing the content of the first number. This is what I want to do. So someone suggests me a prototype for this function. What should be the prototype of such a function? I want to have an add function which will receive two complex numbers, and then it will add the first complex number to the second one, but return the result on the first complex number, inside the first complex number. So someone write me the prototype for such a function. I am waiting in the meeting chat area to see that. Anybody? So add complex T. Okay. So Yunus Emre is suggesting that we actually send the first complex number a pointer to the first complex number, and second complex number could be either a pointer, or he's saying it doesn't need to be a pointer, it can be actually a pass-by value thing. Okay, this is not bad. So in principle, I can say my function should return probably nothing. I don't care, it doesn't return anything, and it's gonna do an addition, and it will do a complex T, and it will be address of the first number. Why? Because I need to modify the content of the first number, first one, and the second number could be either a pointer, or it could also be just a value. So let's assume that it's a value. So complex T is C2. This is one possibility. Okay, let's do this one in that case. What is gonna be the code? So if we actually replace this part with this one, this is gonna disappear, right? I don't need to have this guy anymore, right? C2 is actually a pass-by value. This is gonna stay the same. C1 is gonna be, so I can do it this way. I can say, just change this part, erase this part, put a thing like this. So C1 real, of course, C1 real has to be C1 arrow real is gonna be equal to arrow real is plus equal sign C2 real. So C1 real is C2 real, and C1 imaginary is C2 imaginary. This is what I am gonna have. All right. So if I actually use this guy here, of course, I can do the other way around also. I can do it this way. I can say, okay, let's actually this function be void add, the same thing here. Instead of actually sending me the value, but send me the address of that value, not the value itself, but address of that value. In that case, I'm gonna actually put here complex T C star C2. This is the saying that I want the address of that value, structured value, not the value itself. Perhaps you may want to put a const here, because you know that you are not going to change this guy, but you are going to change this guy. So in that case, another possibility for this one would be void add complex T C1 and complex, sorry, I want to put a const in on top before that. So this will be const complex T pointer to C2. So this will be my second one. In that case, of course, this is going to change. So C1 real is going to become C2 real. Yeah. And then C1 imaginary is going to become plus C2 imaginary. So this will actually now guarantee me this type of a thing. And I know that C2 real and C2 imaginary is not going to be changed because of this const construct that I have in front of the definition there. Okay, so any questions? Any questions? There doesn't seem to be any question. Okay. Now, subtraction is the same thing, right? Subtraction is, in this case, I'm using the passive value, return a value. So my function is this subtract function is going to take a value C1, value C2, copy, and then return a third one as an output. All right. If it was, let's say, if I don't want to do this copying, but I want to just send the address, perhaps I should do the similar things that we have done with the add function. So I will change this one to be pointer, this one to be const pointer, and I don't need this one to be returned anymore. This could be just a void, and I don't need this one anymore. But here I'm going to change this part as this entire part C1 real is going to be C1 real minus C2 real. And C1 imaginary, one imaginary will be C1 imaginary minus C2 imaginary. So this will be my answer if I want to actually just do these things not on the values, send values back and forth, which might be expensive to do the copying. Instead, I will only just send and copy the address and operate on those addresses. That will probably, between these two things, this will actually do copying of, let's say, these are complex numbers are double numbers. So 8 byte plus 8 bytes. So there will be 8 byte for the first one copied. And there will be one copy here, another copy here, another copy here. So there will be at least 3 times 8 by 8, 8 plus 8 copying, byte copying. So this many bytes will be copied in the original one, copied. Now, if I want to actually look at what would happen if I actually send an address is going to copy the first, it will copy this address. And it will copy this address, it will be this. So it will be this many bytes that will be copied. So you can see that instead of copying, let's say, 48 bytes, now you are copying only 16 bytes. So it is 3 times less copying than the first function. The second function in that term, in that respect, is faster probably. Of course, maybe it is not a big deal here, but if your structured variable or structured data is quite complex, meaning it has many, many bytes in it, then this copying could be prohibitive. It could be too expensive for you to actually do it this way. Perhaps in that case, you would actually just do let's say an address form or pointer form of it. Multiplying is again this thing, and dividing can be also this thing. So in this case, it says function divide complex is apparently just returning the first one, and multiplication is returning the first one as well. Why? I don't know. I don't care. So this is the implementation. Absolute value is simply the real parts squared plus the imaginary parts squared and the square root of the sum of these two. Okay, and then you can actually return if this is an absolute valued complex number it's going to be returning, you can do it this way. But if you want to actually return just a double, then you can actually just return here the real part of this thing. It depends on what you are actually, what type of semantics you are applying or requiring your function to actually perform. All right, any questions on this one? Any questions? All right. Questions, let's continue. If you recall, we said one of the, let's say, one of the problems that we were discussing when we were discussing arrays were actually simply like problems like, let's say, keeping a student record. So you might have, let's say, 50 students in your classroom, and you want to actually have a way to, let's say, keep the people's or students, let's say, perhaps IDs and their, let's say, GPAs in place. And if you recall, we actually did this simply using two arrays. One array for 50 students, keeping the name of the IDs of the students. In this case, it's just an integer, right here. And in the second one, the GPAs, the same number of things, and the GPA is gonna be the, let's say, the GPA in this case is gonna be a double array of the same size. Let's assume that, so this is my, let's say, this is my representation. Let's assume that I wanna, let's say, I wanna write a function. I want you to write a function here such that this function, let's say, this function finds a given students with an ID, a given students. So I want to write a function. This is my data. So write a function that, given an ID, returns you the GPA of that ID. GPA. This is the one that I want to write. This function is simple function. I'm keeping some data of a set of students with their GPAs, and I want to write a function, and you tell me, okay, hey, I want to know, for example, the ID number 112233, and I want to know their GPA, all right? So how do we do this one? So let's actually write some code to achieve that. Let's go here. So let's use this part of this thing. So what I want to do is I have my, let's say, my test function here. This is my thing. And we said I want to keep the students' numbers, IDs in, let's say, define max num of students. So this is my number of students. Perhaps I have 100 of them. And I say, okay, this is my students. And my GPAs are kept in another array of the same size. All right. So assume that I have filled this in. Perhaps I have something like this. First 5 students, for example, let's say the first 5 students, the first ID is 1, 2, 3, 1, 2, let's say 1, 2, 4, 1, 2, 5, and 1, 2, 6. So these are the first 4 students, and their GPAs somehow I have. And let's say that first GPA is 3.9 and maybe 2.7, the first GPA, second GPA 3.0. This is a successful class, I guess, 3.8. So these are the things. And I want to know the number of students. I have currently 4 students. So these are my number of students. So let's say that num students. This is what I have. What I want to do is I want to write a function such that if you give me an ID of a student and this data, I'm going to return you the GPA of that student. All right. So let's write a simple function or prototype for this one. The return is going to be what? So the return is gonna be a GPA. A GPA is double, so this is double. GPA of student with ID. This is my function. Okay, so this function is gonna get the student ID, which is integer, student ID, right? Where am I gonna search this for? I'm gonna search this for within these things. I will need to have the students, the IDs, and I need to have the GPAs. So you need to give me this one, as well as, of course, you need to give me also number of students. How many students do you have? I don't know how many students you have, right? So I need to have this one. So let's say that now I wrote this function, assume that I wrote this function. The call is gonna be something like this. GPA is gonna be the ID and the IDs and GPAs, IDs of the students, GPAs of the students, these are arrays, the number of students that I have, currently 4, and the student ID that I want to find out. Let's say that the student ID is, I don't know, I want to know the student with ID 25, and I want to know what his, let's say, let's do it this way, integer student ID. This is 125, and I will actually put this one here. All right, and let's do a printf student as GPA. So here's student ID and this entire thing. This is a potential use of such a function. So what I am doing is I'm saying, okay, give me the student ID, and I will actually take the IDs, GPAs, number of students, and student ID, and I'm gonna find it. So how do we do this one? So let's say that current GPA found GPA is originally 0, I don't know, and I need to go through the entire thing. So for int I from 0 to where till I need to count, do a counting loop, num students, and I will do this, and I'll say, okay, if let's say found GPA is minus, let's say that for the timing this is -1, and if ID I is the student given student ID, then I found it. Then found GPA is gonna be the which GPA? The GPA corresponding to that student. I found the student with the same ID here, and the same index as I did here, 120. The first student has this guy, this first student ID, this GPA, second student ID, this GPA. We can maybe do it this way so that we can see them. It's like this. You can see it here. This is the first student, second student, third student, fourth student, and so forth. So this will actually return the thing. And I will say if found GPA, then I will return the found GPA, return found GPA. Right? This is what will happen. Now, let's look at this code a little bit. This is a very simple thing. What we are doing is we have a number of students, in this case, 4 of them, could be 50, could be 100, could be 1,000, could be 50,000, right? I have IDs for each student, and I have, let's say, GPAs for each student, okay? Now, and when I actually want to write a function to find a given student ID, the GPA of that current student, if that student exists, then I have to actually send the ID, the array with the IDs, the array with the GPAs, and the number of students that I want to actually have in there. All right. this is fine. We have known this one. We know how to do this one. Okay. Okay. Assume that now I want to add to my, let's say, call this as a database. I want to add, let's say, GPA, ID, and let's say, what should we add? Let's say that we add the year of the student. What year in his studies, in her studies, this student is, right? So the freshman is going to be the first year and so forth. Second year, third year, and the fourth year study, right? I want to have that one. Well, I don't know. I need that information so that I can say, for example, I know who's going to graduate this year. And maybe I can give you the average of, let's say, the graduating class, or I can give you the average of the first year students, right? So this is what I want to do. So how do I do this one? How do I actually add to this data? How do I add to this data? This data here. Another information, meaning I want to actually add something more, which is the year of the student. Which year is the student in at this moment? Okay. How do we do this one? The only way to do this one is you define a new, you declare a new array and say, okay, year, okay, and then this has to be the same thing as this guy, of course. And then now I want to actually add the rest of the thing here. Let's say this first student is in his first year. The second student is in her, let's say, third year. Maybe this is, let's say, fourth year. So it is getting difficult, more and more difficult. Maybe this student is also in her first year, and then maybe first year, and this is maybe in let's say in the third year. These are the things. All right. Now you can see that every time I add a new field to this thing, I need to actually increase these things. The number, I need to add another array. And if I want to add, for example, the gender of the student, or let's say I don't know, the number of classes that the student is taking or has taken, and so forth, I need to add one more and more and more number of things here. Okay, this is one problem. The other problem is, let's assume that I add another function, just a simple function. I want to actually print records. So I want to do just print students or print records. I just want to print all the records. So this is going to be very simple, right? I'm going to go through the entire thing from first student to the last student, and I'm going to print here. For example, I'm going to say this is student ID. So ID is this, and GPA is this. See? And then I will say ID is EI, the ith ID, and ith GPA. I need to print. Now, given this function, I want to now add and print the year as well. I want to show the year, which year of this student is, right? So perhaps I have this function here. This is print records here, and ID, GPA, and number of students. Now, assume that I want to actually add this new field, the year field. What is going to happen? What you need to do is for print records to actually print the years as well, you need to actually have added here another one like this. And then you need to go up here and add another one for this guy, which is going to be the year. And then perhaps manipulate this thing here, this part of the code, so that the year is actually written. So here, maybe you say ID and year is this one, and then you have your year here. Now, you can imagine that as I actually increase the number of things in my for my students list, these are the properties that I have, like maybe age, I'm going to put the age there. I'm going to put maybe the name of the student as well. Maybe, let's say, the classes that this student has taken and so forth. So as I increase this, I need to add one more and another and another array. So there has to be a simpler way of doing this thing. And we'll discuss that in the second half of the lecture today. All right, so we'll take a 10-minute break. We'll continue in 10 minutes at 2:30 with the answer to this question. If you have any questions or any comments in the meantime, you can let me know. So I'll stop recording and we'll